Hi, good morning, and thank you so much for joining me in my shop here. It's March 26th, and I'm going to be attempting to check or improve the alignment on this radio. The first thing I want to do is show you my alignment tools. So I went through the bulk of my life up until just a few years ago with just a couple of lousy alignment tools. Really, a real dearth of alignment tools, and somehow I made it all the way to here. But more recently I've acquired a whole bunch of tools kind of by accident. I didn't really put much effort into it. They were kind of given to me. A couple of people gave me some. So let me show you some of them first. If you look down behind my tube tester under all these tools, you'll see a whole set of them running along the wall there. Okay, see them down there? The whole pile of them down there. And I have some small ones in the container here. These are just like specially made screwdrivers, if you like. You could think of them that way, I guess. Because there's so many different radios and so many different things that have to be adjusted and turned, and so many different styles, there are so many different tools. But none of the ones I just showed you are going to work in this radio. But some of these will. Oh my gosh. This is ridiculous. Yes. I got so many alignment tools, I can kind of like do an alignment and just leave the tool on the radio and let it go. I'll never run out. So the ones I need, these are all organized. They're up in this area here. I need one like this. You see it against the black there? It's a little hard to see, but this is a hexagonal tool head here on a shaft. Unfortunately, these plastic shafts are not very stiff, and we have a smaller diameter one here, so this is probably going to be the one. Let me check and find out. It goes right in here. Hard to tell. So, like a lot of things like this, they'll be stuck. I don't think that's fitting in there. Let's try this one. Very hard to tell. Well, I'm going to poke along here until I find one that fits. These are all pretty much the same thing over and over. Why won't it go in there? Is there something funny going on? Maybe there's something funny going on. Maybe it's not what I think it is. Let's take a look right down this hole here, if we can do it. That's going to be a little challenging. Let's give it a go here. I need a super bright light. Wait a second. I've got a super bright light. The camera's blocking the light from going right down. Wow, it looks like I get the impression there's a screw head in there. Oh, I think it's just it's an effect of the light. Let's try this other one. One of them might be closer. Can't see anything in there. Okay, what I'm going to do, then I'll flip the radio over. And we'll take a look here. I'll just turn it this way. Oh, change the camera. Come on, camera, focus. Can't move my arm right. This just looks like a pile of dust in there. One of these got to show up. Well, this hasn't worked. I'm gonna look with my own eye. I can probably see better with my own eye than this camera and whatnot. And I will find a tool, and then we'll get started. Probably could have figured this out just by thinking about it. So a lot of these radios, when you go to align the IF transformers, there's two holes in the top and two flathead screw type adjustments. They're capacitors up here. The other radios, they don't have two screws. They have one hole, and in there is a slug, threaded slug, and that's what you would fit. And I put the tool away now. You'd fit this tool goes into the slug, and then you turn the slug, and the slug is threaded, so it goes up and down and moves its location, and that's how you do the tuning. In some cases, the slug is hollow, and a tool like this go right through it. So you have the slug, and you put the tool in, you can adjust the slug, but you can actually reach past that down further to the second slug. There's two slugs in these things, and you can catch the second slug from above. So there's no need to take the radio out of the cabinet, or at least no need to have it upset the way I have it turned like this. You can do both slugs from above. But if you have a radio like this one, where there's a slug access at the top and also a hole for slug access at the bottom, there's a good chance the slugs are not hollow, and this kind of tool is not going to work at all. Instead, you need just, in this case, a slotted type screwdriver sort of thing. That's this. I don't know if you can see that or not. It's just got a flat head on the top, like a regular screwdriver, really. Plastic end and metal end. And this will do the job, because I could see the slot in the end, and I can put it in. Now the slots in here are wide, so a tool like this, even though this is kind of wide, they tend to go in and they do this thing. Let me get a big screwdriver here and I can show you. So if the slot is the right size for the screwdriver goes in and you get this. But that's not what you get in these things. The slot is usually wide and the screwdriver goes in and it can do this. So it turn this way, and then there's playback until you turn it back this way. This could be a little annoying doing this, but that's what happens with these tools. So when you're putting them in and trying to feel, am I engaged, am I not engaged, you have to have this vision in your head of what's going on in the slot to feel this properly and the like. Okay, we're ready to do the first step of the alignment. I think there are certainly some alignment instructions. We're going to take a look at them first, and just so we know what's in them, and not necessarily well enough to follow them yet. But no, I didn't. Did I put the tool away? No, it's right here. Okay, let's just do that. Let's just jump and take a look at those instructions right now. Okay, now the alignment instructions are spread over two sheets here. Unfortunately, I tried doing something to make it a little easier to look at here. It didn't work. So this is what we got. This is the left side of the page, and that's the right side of the page, and a little bit is duplicated here. So let's go down the right side of the page here. Okay, alignment instructions. Signal generator, connect as indicated in the chart. Use a modulated output. Output meter, connect across voice coil terminals. Okay. Step 1. Connection to the radio. Ground the lead. Ground lead to B-. Output lead through 0.1 microfarad condenser to pin 6 of the 7A8. So dial setting on the signal generator. Oh yeah, signal generator radio. Okay. Dial setting 455. So set your signal generator up to 455. Put the negative onto the B-. Put the positive or the signal line through a condenser or a capacitor onto pin 6 of here. Tuning condenser fully meshed. Adjust tuning cores in accordance with the order given. Second IF, second IF, secondary, then primary. First IF, secondary, then primary. It's not terribly critical you follow this order in a radio like this because the radio is operating. So we know that these are not terribly oops, sorry, whoa, losing complete control here. What happened there? I don't know what happened. What happened? You've lost it completely. There we are. Okay, so I've lost complete control of the whole situation. Here we are. I've regained control. You know, that's a mouse cursor bump. Has that ever happened to you? Bump your mouse and who knows what happened. Okay. So here we are. Radio. So close the tuning condenser or capacitor. Adjust tuning cores. Order given. Right. Order doesn't matter. Look. Now we'll go down to the next one. Radiating loop. So in this case, you're using a loop to feed a signal into the antenna in the back of the radio. You're not actually connecting directly to the radio. So the radio is kind of on its own, tuning this stuff out of the air in my shop, basically. That's the idea here. Adjusted trimmer maximum. Only one adjustment on the oscillator. And same thing, a little less, a little lower frequency. Adjust trimmer for maximum output. Radiating loop made of 6 to 8 turns, 6-inch diameter for insulated wire. Connect signal generator. Yeah, if you don't know how to make a loop, you certainly don't know how to do this alignment, that's for sure. Some symbols we don't care about. Let's look at the other page now. So this is the right side. Here they're showing all the different adjustments. IF primary, C note. Oh, so you see the line is showing dotted. Dot. That's because they're suggesting you're doing it from underneath, not on top. So this gives an interesting hint. This tells us the upper slug is a secondary. And this upper slug is a secondary. So the secondaries are on the upper. That information is very hard to get with most radios. Which one of these two coils inside these cans is primary and which one's secondary. But it's not gonna matter. Set the volume to maximum. Mesh the tuning condenser. Note. So here, this note is referring to the idea that you have to work from underneath the radio. And the last two adjustments are right on the capacitor here. Okay, so I'm going to stop for a minute, then I'm going to give an overview of what it is I'm about to do, and then I'm going to do it. And hopefully this radio's performance is going to improve, because it's not very good at this point, that's for sure. Okay, so the instructions were to connect a signal generator to a particular tube pin. Well, I'm going to avoid that. The radio is closely aligned already. Sometimes those instructions are written as if the radio is completely out of alignment and it's a hunt to even get it to start working at all. With it closely aligned the way it is really not that much requirement, I think, to hook up to the grid of a tube. Instead, I'm just going to continue to use this injection loop. I'm injecting the signal from my signal generator into it right now. Hard for you to see that. What's it? 455 kilohertz. And I'm hoping it'll just go through the antenna, through the first tube, and get to the IF transformers. I'm pretty sure it will. Okay, so we're ready to start up the radio here. I also have this meter connected across the speaker voice coil as instructed. So the volume that we hear should be reflected on this meter. That way we can make fairly precise adjustments and not rely on our ears, which are not so good for that kind of stuff. Let me just see if I can just sort this light out a little better. That's better. Okay, I hear the radio. I'm going to give it the full voltage here. Now, we really don't care about radio signals being picked up by the antenna. So we don't have to tune it to a station, and that crackling is probably going to go away as soon as I get my signal generator happening. Now I'm already feeding the proper frequency at the radio through the antenna. We're not hearing anything. So what I'm going to do here is set this. This is for calibration. Okay, so there's 1,000 hertz tone being transmitted from the signal generator. We should hear it coming out of the speaker, but again, I don't hear anything. So I'm going to vary the frequency of the signal generator in hopes of I'm trying to get the light flash off of this. Not having very good success with it. There we are. Okay. Tune away. Something there very faint. Let me turn this up higher. That's better. Now we can hear something. I turn up the radio. I did my meter go up. What's the matter, meter? Flip to AC. 0.3 volts. It's there. Okay, it's just because there really isn't any sound coming. It's just that hiss is not much of anything. Okay. So it appears to me to be poorly tuned. 455. The reason I say that is because I'm not hearing a nice sharp peak. It's kind of a wide, sloppy sort of thing. Let's see if we can sharpen it up. So I've got this at the right frequency. The meter's working even though you can't see it. Let's start fiddling around here. Let's start with the second IF, the one closest to the speaker. Okay, I'm in. Now we're watching. Hardly making a change. Something going wrong here? That should have a big effect. It's having a small effect. I can see it. You probably can't. That would put it in the middle right there. We'll do the top of the other one just because it's convenient. Come on, Raider, just jump to life. Not much change there either. I'm really hoping this will just... Did a radio the other day, just tremendous improvement. Okay, we're in. We're watching. Wow. There's just no change. I can't hear any change. I don't see any change. Maybe I better follow the instructions properly. My shortcut here may not be a... Okay, go in. I think the width of this is too much. How come I got into every other one? Oh, there's a resistor right there. There's a resistor block on the opening a little bit. No, won't go in. Shoot, I wasn't expecting that. Let's try this. I don't think this will go in. No, it's way too big. Okay, I have to find another tool that's going to fit in there. Okay, let me hunt one down. Okay, so I have one with a thinner shaft, but of course the blade is smaller now. I remember I was showing how it goes in this wide slot. If this gets too small, it really won't work. Let's try it. See how much play there is in the slot. Okay, can we move it? Watching the meter. Yeah, it's moving it. Something's not right here. Something is not right. Something's not right with how I set this up. So put that on full volume. Putting the maximum signal out of my signal generator. It's a very strong signal. Well, it doesn't want to come through the antenna. Maybe we'll have to do what the instructions said and hook it up to to the pin of the tube here. Okay, I'm going to just stop for a little bit. I think that's what I'll do at this point. I'll move it to the tube grid, I believe it is. Okay, so one of the basic principles of safety in a shop like this is to make no connections to the item you're testing unless the power is off to the item you're testing. Now, I break that rule left and right. Who doesn't? Poking voltmeters around and stuff like that. But in this case, I decided to shut it off while I make this connection because this has to go to the B minus, which is reaching right inside the radio. Radio's off now, so I can do this. And make sure I'm going on the B minus terminal here. Okay, because making a mistake with this could have bad consequences. Okay, that's... I don't like it. I don't like it. I'm going to go down here. I'm going to take the negative terminals of the capacitor here. Watch out. Could be charge. Could be charge there. Okay, I think that's a little more rigid. I don't want things moving. And I take a capacitor to make the connection to pin number 6 of the 6A8 tube. Pin number 6A. Okay, well, let's see. 1, 2, 3, 4, 5, 6. This is pin number 6 here. Okay, we'll connect the signal generator once the radio is operating again. I've turned the output way down on the signal generator, so we're not blasting it. And we're still tuned to the IF frequency. Okay, radio back on. Now, did you notice when I turned it on with the dim bulbs, but they didn't light up at all? That's because the capacitors have retained their charge. He says, no, that's not true. Whoops, wrong thing. No, what's true is the heaters are still hot. That's really what. Never mind. Okay, here we go. Now, 450. We should hear this right away. We don't hear it. So this is a very weak radio. Maybe the IF is way out. Maybe somebody fiddled with it and has knocked it way out. So doing this would be important. I'm going to vary the frequency again and see if we can find out what's going on here. Let me turn it up a bit. I can barely hear it. Okay, here we go. Gone. Gone. Seems to be just fine. In fact. I can give it more juice. What's going on with my meter? Turn it up. It's just such a very low voltage. That's full blast. So that should be a pure, clear tone with the kind of power I'm sending at it. Okay, well, let's give it a try and see what happens. I'll go right for the one I couldn't do last time. I'll use the right end of the tool. Okay. What happened there? I'm watching that meter. So, based on what I can hear, ooh, that sounds terrible. A lot of what you're hearing there is this surface dragging over top of wires as I'm turning it. That's what you're hearing. Well, let's just keep tuning these guys up until something good comes of it. There's a microphonic tube in here. This one. And in worst case, this can actually cause feedback the speaker can shake the radio, shake the tube, shake the elements, and cause the tube to send the sound through again and get feedback that way. Okay. But mostly we're hearing it because the volume's up full blast. I wonder if, that capacitor with the, I won't talk right now. Well, most of the radios, when you do an alignment, the needle's moving up and down quite distinctly. This one, not at all. Let me stop for a minute here. I think right now we're putting the test signal into the first tube. It's going through this IF transformer and another one you can't see just back here. There is a way to send a signal, skip the first one and just right into the second one to see what's going on there very clearly, rather than trying to work through 2 or 4 adjusting things at once. The idea is to get them all lined up like that. But I mean, if they're all over the place, you can move them around quite a bit and never hit the mark where they do this. That's what I suspect is happening here. That's what I hope is happening here, because that's resolvable. Okay, so I'm going to stop for a little bit, and then we'll study the schematic and figure out where to make a connection and feed the signal right at the second IF transformer. Once again, because this schematic's on 2 pages here on my computer, it's a little hard to look at, but we were injecting a signal into this tube, and then that signal is working its way through this transformer, which we were trying to tune, and the other transformer, which is on this transformer. In between those 2 transformers sits this tube, the IF amplifier tube. We'll see it on the top page better. Here it is here. So what I want to do is, rather than fire the signal through this tube, through this transformer, through this tube, and through the last transformer, and then out to the speaker, I want to inject it into this tube. Then it will just go through this tube and into the coil, the transformer. Now you might say, why not just inject it right into the transformer? That'll disturb the tuning of the transformer, hooking up any equipment to it. But if you hook it up here, this is where I'm really going to look for, then the tube will isolate my signal generator away from the circuit. It won't disturb the circuit at all. So we want to get on here, pin number 6 of the 14A7. And okay, that's what we're going to do. Pin 6. Pin 6, I said with authority. So the IF tube is this guy right here. And pin 6, I said. Take this off here. The radio's not operating right now. And pin 6. Okay, I'm going to count them here. 1, 2, 3, 4. Oh, 6 is almost inaccessible. Oh my gosh, it's way up in the back there. Let me count them again just to be sure. 1, 2, 3, 4, 5, 6. Oh my gosh, I can't get a clip in there. Okay, so there's a wire. Comes off it and goes to here. I can certainly put a connection on there. So put it here. Okay, so that amounts to the same thing. So we're ready now to inject the signal into the second transformer. Well, it looks like the first transformer. Yeah, I got the wrong transformer here. How did I do that? No, that's right, because the signal's coming out of the first transformer into the grid of this tube. Then I've intercepted that connection and stuck this clip lead on it. I'm going to shove a signal into it. That's right, I got it right. Okay. Signal generator still roaring away here. Let me turn it down a little bit. Okay, power going on. Dim bulbs flashing. Such excitement. Here we go. So I think I left the volume right up too. Let me get my fingers on that quick. Nope, volume right down. Volume right up? Yeah, volume right up. Let's turn it down. I'm not hearing anything. Let's give it the full treatment here. Why so quiet? Hooking up this may have just silenced everything. Let me disconnect here. That's exactly what's happening. That's fine. Now we're going to feed a signal in here, and we should hear it. Signal at 455 coming out of this guy here. There it is. And it sounds much clearer. I'm going to turn the volume up. Okay, meter's up a little bit now. There we go. Okay, so correct frequency here. Here we go again. Second IF is this can back here, I'm pretty sure. Let's turn it a bit and watch what happens. Down. Down. That's the peak. That's all there is. Okay, coming underneath. Oh yeah, I can't get in there with this tool. Right. Underneath with the other tool. The impression I get is we're not going to gain much here. That's the impression I'm getting. Come on, go in the... There we are, we're in, watching the meter. No, it's right on the same way I had it before. So, I can't do anything about this one. The signal's being injected past this one. But we already tuned it. There's nothing, it's just not coming up the way I would expect it. So if alignment is the issue, it would have to be the other alignment factors, and they are just not that significant. One is tuning the local oscillator, which will just shift where the signal's picked up on the dial. It's a little more than that. And the other one, the other adjustment is to compensate for the antenna, but it's probably already been adjusted and compensated for. How much more can it? You're just not going to get a lot of boost here. Or, man, I'm totally wrong, and the radio actually has lots of strength, and there's no problem here. That's what I'm really discovering. There's no particular problem here. Okay, let's shut it off and disconnect this stuff. Okay, I feel a little better with that clip lead not in there. Let's just play the radio. I almost said play the bloody radio. Yeah, a little bit of a... So my British training, you know, I'm in a Commonwealth nation, so even though my background is actually Scandinavian. Okay, my grandparents lived in a Swedish part of Finland. How's that for confusing things? Caused me a lot of confusion. Turn it down. We're going to set up the antenna booster here so we can use it if we need it. I think I got to run and switch the antenna down here. Just sit like that. That's good. Okay, radio's off, everything's off. That's a perfect time for me to take another break. Why not? Watching a documentary on Paul Dirac. Okay, so the next step is to tune the radio to 1600. Okay, and I think you can see I put the dial on the radio, and you can see the markings here. Now, 1600 right at the end, or is it a little bit up this way? How can I tell? The the other end, I don't know, because it's out of the cabinet. The cabinet, whoops, sorry about that noise there. Cabinet has a dot right on the top, so straight up, straight up. So you know, when I look at this, like this is not very precise. Can you see that right above the 160 here, which is 1600 in fact? You can't see it there. There's a little dash. You see the brown dash, dash, dash. Now most radios, those are dots. You can see the dash down here quite clearly. Those are dots. In this radio it's a dash. Why? They're admitting how inaccurate this dial actually is. So anywhere in this range gonna do the trick. And so and also AM actually extends up above 1600 now to 1700. And this radio, like most of these old radios, can't get there. And what's up above 1600? Some community type radio stations are very low power, so there's not a lot to get up there. There's a good station that's 1690 that plays that I can pick up, that plays 70s, 60s, and 70s pop music, and that this radio won't get there. I think 1600 is straight up like that, and I would say 55 is like that, not right at the end. There's a dot there. Now that's interesting. Why would they put a dot there? Usually this is a dial setup indicator or something to, but this dial is fixed in place with the capacitor. It's just a straight through shaft. There's no string, there's no gears, there's no nothing. So you don't have any choice. So I don't know why they put a dot there. So I would say that's 550, something in that range. This is going to be tricky to do. So we'll do the 1600. Okay, I'd say that's 1600 straight up. And we'll see what happens. I don't expect a big change anyway in the radio's operation. So first thing is to adjust the local oscillator in order that the radio tunes 1600 at 1600. And then the second thing is to adjust for the antenna. And again, I just don't think there's going to be much to be gained there. We will see. Maybe I'm totally wrong. Okay, power on, and the two things we're adjusting here are these little screws here. Okay, let me get a good tool to do that with. This one looks good. I'm going to just make sure these are loose. Yeah. Sometimes these are really stuck. No. Okay. Oscillator will be the one with the smaller capacitor, would be this one. So that's the first one we will try, assuming it doesn't tune 1600 at 1600. Okay, away we go. Power on. So some of these radios I've been changing the light bulb to an LED version, a 6.3 volt LED light. But I would never do it in this kind of radio because the light bulb is not fed from a transformer. It's fed from a tap on the heater of the rectifier tube, and I just think that's probably not the best place to put a LED style light because of the variations in the voltage in that. Hello, hello. There we are. Okay. Now I have 1600 dialed up here. I don't hear it. Let's hunt around. Maybe I don't have it strong enough. I guess put stronger signal. We better find it. Extremely weak here. So that's way off. That's way off. So let's move it. And maybe this will... In the last case, I was trying to align four things. Get them into alignment. 4 adjustments. In this case, I'm really not even... Yeah, I'm kind of doing 2, but it's not even that tough. He says, what are you talking about? I don't know. Somebody think I know what I'm doing here? Okay. And the meter's connected too. So here we go, oscillator. Now, I don't want to lose track of what I'm doing, so I kind of have to, come on, get on there. There we are. So what I try to do is what I call hopscotching. I move one device and then the other device and work my way. There you go. The explanation of that. I can barely hear this. I don't like it. Why is there no modulation? That might be the reason right there. Okay, we hear a little bit now. How's our meter doing? Meter's showing next to nothing. Okay, now we're cooking. Here we go. Okay, first thing we gotta figure out is which way to turn this. So I'm gonna move this. And I'm gonna try to find it. That way, okay? So we're gonna go this way. Now we're gonna find it. That's where we are. We're gonna go further. There it is. We're past. We're heading to 16. It's getting louder and louder as I go. I think. Getting better. And here the microphonic tube is allowing you to hear the movement of the screw. That funny little. Okay, right past a bit, and now we'll come up here. Scratchy. Okay, we're almost there. Where'd you go? That doesn't sound like it. Okay, coming in on 16 now. That's about as close as we're going to get there. Okay. So download reads 16. The radio's receiving 16. But barely. Oh, my loop fell off. Oh, that helps a bit. And still, I'm putting a strong signal through this loop. This is a weak radio right now. It still is. So, but we've got it tuning. Oh. Ooh, lots of nonsense in here. What's going on? All kinds of nonsense. So it should not be picking up this signal below 1600. That's a very strange thing right there. There's the real. No? So a couple things here. One, I could be overloading the radio tremendously. I got a huge signal going into it, so I'm going to cut it back because they always say do this with the least signal possible. But this is not much. Wow. Okay, see, those funny things are still there. I've definitely turned down the. Still there. Still picking it up in the wrong spot. Something way down here. Okay. Here's the situation here. Very weak radio. Doesn't seem like I can boost it up with alignment. There's one capacitor left in this radio. This capacitor has a coil in the capacitor somehow. And there's a statement on the schematic that says, this fancy capacitor is the reason why the IF works so good in this radio. Extra good. You put that coil in there, extra good. But what happens if the capacitor gets weak? It could be that's what's happened. The capacitor has become weak or leaky, which might not help either. And the result is, regardless of the fact that there's a coil in there, the radio's become weak. So now I have to ask myself, what am I going to do here? I could replace the capacitor and forsake the coil. If I forsake the coil, the engineer might come running in my shop here at any moment and say, you don't have that coil in this radio. It's never going to produce any decent volume because we designed it around that special coil. So you got to have that coil in the radio. So that's kind of what I'm facing now. We want to make this radio work because it's really not going to receive anything, I don't think, on its own antenna all by itself. I think we have to deal with that capacitor and coil. And exactly how I'm going to do that, I'm not sure. So maybe the last thing we'll do is take a peek at the schematic, and then I'll call it a day here, and that'll give me a day to think about this before doing something foolish. Let's look at the schematic here. So the capacitor I'm talking about is this one here. Let's look at it on the other page. Here it is. C303, and this, they show this coil, and then there's a comment. Where was the comment? I don't know where the comment was now. I'm going to have to go looking through this whole thing to try to find the comment. Incidentally, these troubleshooting guides, I guess these are helpful, but if you look at them and you see, okay, let's suppose you're having this problem, voltage not right or low voltage, and you look at the list of possible things that could be going wrong, it's actually not that helpful. Some of these lists are really long, like 8 different things could be broken. So how's that helping you really? Look at this one. Could be this, could be that. You can probably figure these things out yourself. Like home in on the component that's in trouble yourself without reading these charts. That's my only comment. I'm sure they're helpful, especially if you're stuck, you don't know what to do. Yeah, this would give you something to do. But I personally believe that just a direct troubleshooting will get you to the problem faster than studying these charts. Okay, that's just my opinion. And what are we doing here? So we're going to, so I want to look at this guy and just think a bit about it. Say what the value of this is. What is the value of it? Does it say it in the parts list? It was 303, wasn't it? 3, well, here. No. Here we are, 303. 303. Condenser special IF bypass. 0.2 special. They're not telling you anything more about it. Okay, so somewhere in the writing I think there was something said about it. I'm going to go look for that. Okay, here it is right here. I'll read it. Condenser C303 is a special condenser, inductively wound to form a series-tuned circuit, resonant at the intermediate frequency. This condenser offers less impedance at this frequency than a conventional condenser, and thus permits higher IF gain. Let's see. This condenser offers less impedance at this frequency. Yeah, if you have a tuned circuit, and a series tuned circuit at resonance has no reactance. or the reactance of the two components cancels each other out and you just have resistance. And what would the resistance be through there? It would be pretty much zero. So you'd have a very, very solid grounding. If you stuck a capacitor in there, no matter how big you make it, there's going to be some reactance in the capacitor. It's going to be a little less grounded than it would be. And they use this technique. Now I can see what could happen here. If the condenser value, it's microfarads, goes off, then this is no longer tuning at the right frequency, and it's no longer providing this function of permitting higher IF gain. And my guess is it goes the other way. It gets really bad really fast. So we could replace this with a very large condenser or capacitor. I'll get back into our time period here with a big capacitor and forget the coil and pray it's better. So I could do this by nipping one lead on the existing capacitor and in preparation to reconnect it should everything not work out, and then put in a substantial capacitor there and see what happens. And how big is 303 anyway? How big is 303? 303 is at 0.2, so it's a fairly large capacitor to begin with. Special IF bypass. The engineer was probably really proud of this. That's my guess. Something special. I haven't seen this before in another radio. And when they say the condenser has been wound in such a way, I wonder what they mean by that exactly. So, okay. So the plan tomorrow is to experiment with this in some rational way and determine if this is the cause of the weakness in the radio and maybe what we can do about it. I don't know. We'll see. So thanks a lot for watching today. We'll see if we can get this guy working properly, because at this point I don't think it's a usable radio. I think if I put it all back together and take it outside or somewhere out of my shop is a bad place to receive radio. I don't think this thing's going to do anything good. Okay, that's it. See ya.